Good morning, everyone. Myself, Devika, working as Assistant Professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Now, I am going to cover the subject on control systems, which is a core subject for fifth semester in Electrical and Electronics Engineering. Then, I explain the main objectives of the control system course. Firstly, this course helps students understand different ways of representing systems such as block diagrams, transfer functions, and state space models. Secondly, students learn to analyze the stability of linear systems in the time domain, which helps us understand how a system responds over time. Thirdly, the course also focuses on frequency domain analysis, which is important to study system behavior using frequency response methods. Next, students are trying to develop linear models, mainly using state variable models and transfer function models. Finally, the course enables students to design compensators based on time and frequency domain specifications, which improve systems performance and stability. Overall, these objectives prepare students to analyze, design, and control real-time engineering systems effectively. Then, the syllabus to be covered in Unit 1 deals with the modeling of linear time invariant systems. In this unit, we learn how to represent systems using mathematical models. Unit 2 focuses on time domain analysis, where we study system response characteristics such as rise time, settling time, peak time, and stability. Unit 3 covers frequency domain analysis, which helps us understand system behavior using frequency response methods. Unit 4 explains state variable analysis, where systems are represented using state space models for better analysis and control. Unit 5 deals with the design of feedback control systems, which helps improve system stability and performance. Overall, these 5 units provide complete knowledge of analyze and design of control systems. Then, why we study control systems? Control systems are used to design and manage dynamic systems such as electric motors, power converters, and automation process. They help us ensure that systems work in a stable, efficient, and accurate manner. In electrical engineering applications, control systems improve performance, reliability, and precision by reducing errors and maintaining the desired output. Therefore, studying control system is essentially for developing modern and advanced electrical technologies. Now I am going to see the topics: definition of control system, classification and applications, transfer function of the system, signal flow graph, and application of SFG. Now, definition of control system. Control system is an interconnection of components arranged to achieve a desired output or response. The main purpose of a control system is to control, regulate, or manage the behavior of dynamic systems. It is classified into two types: open loop control system and closed loop control system. Then, open loop control system. It is one in which the control action is independent of the output. That means there is no feedback in the system. For example, ceiling fan, washing machine, electric toaster, hand dryer. In ceiling fan, the speed of the fan is controlled manually using a regulator. The fan does not check the actual speed, so it is an open loop system. In washing machine, in a timer based washing machine, the washing machine process runs for a fixed time and does not depend on how clean the cloths are. In electric toaster, the toaster heats the bread for a preset time and does not sense whether the bread is properly toasted. In hand dryer, it works for a fixed duration once switched on and does not monitor dryness in basic models. Then, closed loop control system. It's one in which the control action depends on the output through feedback. For example, automatic voltage regulator, speed control of motors, air conditioner. In automatic voltage regulator, it continuously monitors the output voltage and automatically adjusts it to maintain a constant voltage even when load changes. Then next, speed control of motors. In this application, it is sensed and compared with desired speed. If there is any error, the system corrects it automatically. In air conditioner, the temperature is continuously measured using a sensor. The air conditioner adjusts cooling based on the room temperature to maintain the set value. Then we are going to see the transfer function of the system. How to determine the transfer function of the system. Transfer function means it's a mathematical representation that shows the relationship between input and output of the system in the Laplace domain. For example, input denoted as R of S, output is denoted as C of S means we have to find the transfer function of the system T of S equal to C of S divided by R of S. It is useful for system analysis, stability study, control system design. Then we are going to see the topic signal flow graph. Signal flow graph is a graphical representation of a control system that shows how signals flow between system variables. Then some important definition of signal flow graph. First one, forward path and forward path gain. It is a forward path means it is a path that connects the input node to output node. Input node denoted as R of S, output node denoted as C of S. It follows the direction of signal flow. No node is repeated in a forward path. Then forward path gain. It is the product of all gains along that forward path. For example, input node R of S, output node C of S, forward path gain P1 is equal to G1, G2, G3, G4. Next, individual loop gain. It is a closed path that starts and ends at the same node. The signal follows the direction of flow. No node is repeated except the starting node. Then individual loop gain. It is the product of all gains around the loop. For example, in a closed path, so the node 2 to 3, 3 to 2, it is a closed path. So the gain of the individual loop gain is minus G to H1. Likewise, L2 and L3. Then non-touching loop. This loop that do not share any common node. They are independent of each other. These two loops do not touch, so they are non-touching loops. Then input node. Input node has only outgoing branches. It represents the input signal. Then output node has only incoming branches. It represents the output signal. Then we have to find the transfer function of the system by using Moissan's gain formula. T of S equal to C of S. Laplace of output divided by Laplace of input is equal to sum of all Pk del k divided by del. Pk means gain of kth forward path. Del means determinant of the graph. Del k means del minus sum of all gain terms in del that touches the gate forward path. By using this Moissan's gain formula, we can determine the transfer function of the system. Here I have solved one problem related to signal flow graph. Find C of S, R of S for the given SFG. Here, 5 nodes are here. R of S is input node, C of S is output node. First, we have to solve forward path gain. So, forward path gain, we have two forward paths. So, P1, where we have to find P1 and P2. So, in forward path gain, that connects the input node to the output node. Okay, so input R of S to C of S in only forward signal only. So 1 to 2, 2 to 3, 3 to 4, 4 to 5. This is the first forward path. So gain of this forward path gain P1 is equal to G1, G2, G3, G4. Then second forward path 1 to 2, 2 to 5. So the forward path gain of P2 is equal to G1, G8. Next, we have to solve individual loop gain. Means we know that it is a closed path that starts and ends at the same node. No node is repeated except the starting node. So here we have three individual loop gain. First individual loop gain 2 to 3, 3 to 2. So it is first individual loop gain. So we denote it as L1. So L1 is equal to minus G to H1. Then 3 to 4, 4 to 3. This is second individual loop gain. L2 is equal to minus G3 H2. Then third individual loop gain is 4 to 4. So L3 is equal to minus H3. Next we have to find del 1. Del 1 is equal to 1 minus sum of all individual loop gains. So, sum of all two non-touching loops. Here, there is no non-touching loop in first forward path gain. So, we have 0. So, del 1 is equal to 1 minus 0 is equal to 1. Then del is equal to 1 minus formula. We know that del is equal to 1 minus sum of all individual loop gains plus sum of all product of non-touching loop gains taken at a time minus sum of all product of non-touching loop gains taken 3 at a time plus etc. We have here we have only two non-touching loops only. So the formula is del is equal to 1 minus sum of all individual loop gains denoted as L1 plus L2 plus L3 plus we have only two non-touching loops. So L1, L3. So here we have to substitute these values. We have to find del values. Then we have to determine the transfer function of the system. T of S is equal to C of S divided by R of S. We know that the formula. We have to apply P1, P2. We have two forward path gain. So K is equal to 2. P1 del 1 plus P2 del 2 divided by del. We know all these values. So we have to substitute these values. Then we have to find the transfer function of the system. Then advantages of signal flow graph. It shows the system in a simple and clear diagram form. It can also represent more than one input and output easily. It makes system analysis easy by using Moissan's gain formula. Then disadvantage of SFG. It becomes difficult to use for very large systems. It is applicable only to linear systems. Then application of signal flow graph used for analysis and design of control systems, and it applied in electrical and electronic circuits. It and used in mechanical and aerospace systems. Thank you.